My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 389. In this lecture, I will continue my discussion on geometric intuition of decision tree. Before understanding this lecture, I request you to go through my previous lecture, that is lecture number 388. This particular simple code we discussed in our if else code in our previous lecture. This is basically nested if else condition that we converted into a diagram. That diagram is known as decision tree. What does this mean geometrically? If I have two features, here my first feature is, what is my first feature? Here let me assume petal length I am taking on x-axis. My second feature sepal length I am taking on y-axis. So what is this decision making? Petal length less than a. Just petal length PL less than. Let's call this is decision 1. Just I am saying petal length less than a is my first decision, that is decision 1. This decision petal length less than a, what does it mean? If you draw a point A, just keep point A here, point A on petal length, this is petal length on x-axis. What does this represent? This represents the hyperplane pi 1. What is that hyperplane pi 1? This is corresponding to the this one is corresponding to PL less than A, petal length less than A. I am taking petal length on x-axis. I am indicating this as A. If petal length less than A means what? Petal length less than A means this is the region, isn't it? Corresponding to every decision, this is one decision. Corresponding to every decision, you have hyperplane. This is the hyperplane. This is the hyperplane for corresponding to PL less than A. What is this decision? Your decision is yi equal to 1. This region is belongs to yi equal to 1. Just say this is yi equal to 1. Anything left of this pi 1, anything this left of pi 1, that is yi equal to 1 is declared. If it is no, then what does it mean? That means if PL less than A, yes means yi equal to 1. If it is no means, that means what is the region? This is the region. No means what? Less than A, no means it's a greater than A. This is the region. Then if it is no, where we have to go? Sepal length less than B, isn't it? If it is no in the region, petal length less than A is not less. This is no means what? Not less than A. We have, in that case, where we have to go? We have to go sepal length less than B, isn't it? Let's say my sepal length is here. Let me indicate sepal length. Otherwise, let me take yes. Just say this is B. I am taking. Let's say my sepal length is here. This is my B. Now I don't look at this region, isn't it? I don't look at this region. This region is declared as y equal to 1, isn't it? This region already accounted. What is sepal length less than B? Sepal length less than B. So this is the hyperplane, isn't it? Petal length less than A, false means no. No means false. False means greater than A. And sepal length I am taking on y-axis if it is B, and sepal length, what it says? Sepal length less than B. Less than means this is the region. What is your decision? If it is yes, less than B. If it is yes, yi equal to 2. If sepal length less than B, no. Sepal length less than B, no means what? What can I say? What is sepal length less than B? So this is the sepal length less than B means yi equal to 2, isn't it? This region, in this region, what do I have? In this region, I have petal length greater than A, and also, and my sepal length, this is sepal length less than B. So here, what is yi? Yi equal to 2. What about this region now? What about this region? If you look at this region, in this region, third region, corresponding to decision 2, This is decision 2. Corresponding to decision 2, we have hyperplane pi 2. Let me indicate like this. Yes. Just see this one. Corresponding to decision 1, I have pi 1. Corresponding to decision 2, I have pi 2. Isn't it? We have corresponding to decision 2, we have hyperplane pi 2. Corresponding to decision 1, I have hyperplane pi 1. Now, you have broken whole thing into 3 regions because you made 2 decisions. How many decisions you made? This is one decision. This is another. You made 2 decisions as that whole this region is called related to y equal to 1. This region is called related to y equal to that. This region is third region, that is y equal to 3. Isn't it? Now, one very important thing is all of your hyperplanes are these are hyperplanes. This is hyperplane, isn't it? What is yi equal 3? Yi equal 3 means petal length less than a? No, means petal length greater than a. Greater than a means this region, and sepal length less than b. Less than b means no. No means what? Greater than b. Greater than b means this region. This is the yi equal to 3. Anybody can understand this simple diagram, isn't it? What are the hyperplanes here? What are the hyperplanes? Pi 1 is one hyperplane which is parallel to y-axis. Pi 2 is another hyperplane which is parallel to x-axis. Isn't it? All pi 1 is hyperplane, pi 2 is hyperplane. Therefore, a hyperplane which is parallel to whether x-axis, that may be parallel to x-axis or y-axis or any of the axis. If you look at pi 1, here pi 1 is parallel to sepal length, isn't it? Sepal length is axis and pi 1 are parallel to each other. Similarly, your pi 2 is parallel to petal length. This is pi 2 is parallel to petal length because you are using less than type of constraint for the simple decision trees that we discussing here. All separating hyperplanes, all are decision hyperplanes are parallel to either x-axis or y-axis. Even in high dimensional space, same thing will work. So all the hyperplanes in a decision tree are axis parallel. So geometrically speaking, a decision tree is nothing but it is basically set of or a bunch of a set of or group of axes parallel to hyperplanes that divides the whole region into hypercubes or hypercuboids. If you think decision tree programmatically, they are nothing but nested if-else statements, isn't it? Just see, there are all of your hyperplanes are axis parallel in decision tree, isn't it? It is simple. You can understand decision tree is nested if-else statements programmatically. Decision tree is set of axis parallel hyperplanes. Just go through this lecture. If you have any difficulty, please keep a comment. In my next lecture, I will discuss about simple decision tree. Thank you very much.